Hello, before we get started, I just want to remind you that because this is a video, you can pause it, rewind it, go through the pace that you want to go through it at, and just remember to take notes like you would any other lesson. So this lesson is lesson 1, properties of integer exponents. We're going to start with negative exponents, but before we start with those, we're just going to kind of review positive exponents. So up in the upper left-hand corner of the screen, it says positive exponents indicate repeated multiplication of the base. So that means that I'm taking a number and multiplying it over and over again as dictated by that little raised number. So this is read as 5 to the third power. And that means that I'm taking 5 and I'm multiplying it together 3 times. So the 5 is what we call the base. And then, of course, that little 3 is the exponent. So negative exponents are just the opposite, right? Like a positive and a negative are opposites. So positive exponents are repeated multiplication. That means that negative exponents indicate repeated division. So like positive exponents or positive and negative numbers are opposite, and multiplication and division are opposite. So it makes sense for them to be related in that way. And then dividing a number is the same, or dividing by a number is the same thing as multiplying by its reciprocal. So usually when we do have negative exponents, we don't actually like divide. We multiply by the reciprocal over and over again. So an example of that is down here. It says 5 to the negative third power. So instead of doing like 5 divided by 5 divided by 5 as many times as we need to, we can just take that 5 and flip it into its reciprocal, which the reciprocal of 5 is 1/5. Reciprocal is just like the flipped version of a fraction, essentially. And then we can take that 1/5 and we can multiply it 1, 2, 3 times together because the exponent was a 3. So just kind of notice that when we go from having the like negative exponents, having the positive exponent, or I guess when we go from having a base to its reciprocal, the exponent changes from negative to positive. Another way of kind of viewing this is through a pattern, like with this table on the right. So when I fill in this table, I'm just going to start with what I know, which I know 3 to the first power is 3, because it's just 1 3. And then 3 squared, that means 3 times 3, which is 9. And then 3 to the third power is 27. So if you notice on the right side of the table, or as we go to the right, I guess, we're multiplying by 3 each time because we're going up by a power of 3. And then as we go left on the table, though, we're like dividing by 3 each time. Like this is divided by 3 to get 9, divided by 3 to get 3. So as I go to the left, I'm just going to divide by 3 a few times. So 3 divided by 3 is 1. And then if I divide by 3 again, 1 divided by 3 is 1/3. If I take 1/3 and divide it by 3, I get 1/9. And then if I take 1/3, I divide it by 3, I get 1/27. So just kind of notice the like relationship between the numbers on this table really quick. So like 3 squared was 9, and then 3 to the negative second power was 1/9. So it's the same number, it's just the reciprocal. And then when I had 3 to the third power is 27, 3 to the negative third power is 1/27. So I'm getting like the same value, just the reciprocal of the original one, basically. So a couple different types of examples. When we have a positive integer base, one thing that you can do is you can just kind of think of it as, I guess, a fraction. And then we know that negative exponents make the base turn into its reciprocal. So instead of 2/1, I'm going to think of it as 1/2. And then that negative 5 exponent is going to turn into a positive 5. And this basically means 1/2 multiplied out 5 times, like 1/2 times 1/2 times 1/2 times 1/2 times 1/2. Instead of writing it all out though, we can just raise both the numerator and the denominator, the top and the bottom of the fraction, to the 5th power. So like 1 to the 5th power is 1 times 1 times 1 times 1 times 1. which is 1. And then next I would have to do the same thing to the denominator because it's in parentheses. And I know I put it in parentheses, but whenever you have like a fraction to a power, you do want to include those, just so we know that the power is going to both. So 2 to the 5th means like 5 2's being multiplied, which ends up being 32. And then the next one, when we have a negative integer base, I'm just going to treat it the same exact way. So I'm going to make this over 1, and then I'm going to flip my base. So instead of -4, it's going to become 1 over -4. And we usually don't put the negatives in the denominator, so I'm going to actually, oops, sorry, I meant to erase my negative. I'm just going to throw the negative in front. So out in front of my fraction. It can also go like kind of in the numerator. Either one is fine. We just don't usually write it in the denominator. So I have -1/4, and then now my -3 exponent is going to turn into a +3. And that means that I'm taking -1/4 and I'm multiplying it out 3 times. I actually am going to write this one all out though. So -1/4, -1/4 times -1/4. And then it's really important to know what kind of goes on with negatives once you multiply them. So I'm just going to say that the negative is going to go with the 1 in the numerator and not with the 4. It cannot go to both. You just have to kind of pick a side. So I'm going to say -1 times -1 times -1, which is -1. So if you have an odd amount of negatives multiplied together, it stays negative. If you have an even amount of negatives, it turns positive. And then we'll multiply straight across the denominator. So 4 times 4 times 4, which is 64. So we end up with a -1 over 64. And I forgot to highlight the first answer, which was 1 over 32. Okay, so the third one, now we have 5 6 to the -2nd power. So I can't have this negative exponent there. That's a problem. The problems aren't considered simplified if they have a negative exponent. But I know how to turn it to positive. I just have to flip its base. So instead of 5 over 6, it's going to turn into 6 over 5, or 6/5. And that's going to change the exponent from -2 to +2. And then now I just need to raise each the numerator and the denominator to that power. So instead, you can expand it if you want to, kind of like what we did with this problem. Like I can do 6/5 times 6/5 and then multiply straight across. Or I can just take them and both square them. So 6 squared is 6 times 6, which is 36. And then in the denominator, I have 5 squared, which is 5 times 5, which is 25. And then they don't have any common factors or anything, so I'm done simplifying from there. And then for the last one on this line, 1/2 to the -3rd power, I have a negative exponent, but we know how to get rid of those. We just have to flip our base. So instead of 1/2, I'm going to flip that to 2 over 1. And that's going to turn my -3 exponent to a +3. But if I have something over 1, any number over 1, I don't need to write it. 2 over 1 is the same thing as just like 2. And then if I don't have a fraction, I don't really need those parentheses anymore, so I technically don't need to write those, but you definitely can if you want to. It doesn't change the final answer. So now I can just do 2 to the 3rd power, which is 3 2's multiplied together, so that is 8. So now we're getting into a couple more complex examples. So it says when you have a negative exponent in the denominator, you can move it to the numerator to become positive. So numerator and denominator are just different ways of describing like the top or the bottom of a fraction, basically. So just as a reminder, the numerator is the number on top and the denominator is the number on bottom. Okay, and then it says if you have a negative exponent in the numerator, so on top of the fraction, you can move it to the denominator to become positive. So basically what that means in a little bit more simple terms, if you have a negative exponent, it just flips to the other spot. So if it starts on top, it goes to the bottom, and if it starts on the top, if it starts on the bottom, it goes to the top. So the first problem, we have a negative exponent. We have this like 3 to the negative second power down here, and I need to make it positive. Since it's in the denominator, it's just going to move to the numerator, to the top of the fraction. So I'm going to set up a fraction. I'm going to leave that 1 out in front, and then I might take it away in a second. But that 3 to the negative second power is going to come up, and it's going to get multiplied by whatever is already there. So I have 1 already there, so I'm going to multiply that by the 3 to the positive second power now. And then since I moved that 3 up, there's like nothing left in the denominator, so I wouldn't leave a 0 there because that would make it undefined, so there's going to be a 1 left over there. But I mean, I know multiplying by 1 is like the same thing as whatever my original answer is, so I don't really need to write that 1 times. And then dividing by 1 also doesn't change my final answer, so I don't really need to write that, but you definitely can. It won't impact whether your final answer is right or wrong. You would just want to simplify it all the way. So now I just need to do 3 squared, which is 9. So next part says 2 to the third power over 4 squared times 5 to the negative 2. So anytime I have a negative exponent, I need to flip it to kind of like its opposite location. So I'm going to take that 5 to the negative second power and I'm going to move it upward. So I have a fraction. I'm going to set up my fraction bar. I'm going to zoom in so it's a bit easier to see. So that 2 to the third power, this one right here, is staying there. I'm just going to leave it there because it has a positive exponent, so it's not moving. And then now this 5 to the negative second power, it's going to flip up, and it's going to become 5 to the positive second power. You don't need to change that like 5 to a 1/5 or change it to its reciprocal or anything. That's what we're doing by moving it to the numerator, is getting its reciprocal basically. And then this 4 squared, we're just going to leave that in the denominator. So when they have a positive exponent, they stay in the same spot. If they have a negative, they flip. And then now we'll just go ahead and simplify. So we can't multiply like the 2 and the 5 together because they have exponents. So we would want to use exponents first. Hopefully you remember order of operations a little bit. I'm going to go down to it really quick. So you may have learned it as either PEMDAS or GEMS. But just as a review, we would do parentheses or grouping symbols first, and then exponents next. Then is multiplication or division, depending on what comes first in the order, and then addition or subtraction. So we just have multiplication and exponents here. So we'll do our exponents first. So first I'm going to do 2 to the third power, which that means 2 times 2 times 2. 3 2's multiplied together, which is 8. And then next I have 5 to the second power, which means 5 times 5, which is 25. And then down here I have 4 squared, which is 4 times 4, so 16. And then I just want to keep simplifying and work on reducing if I can. So in the numerator I have 8 times 25, which is 200. And then over 16. And I can't divide 200 by 16 evenly, you get like 12.5. So I don't want you to change it to a decimal, I want you to reduce the fraction, which means dividing by a common factor. So I know that a common factor of 216 is 8. If you didn't know that, you don't have to reduce all in one step. You can just kind of reduce by smaller numbers and you would get to the same answer after a few extra steps. So for example, like 216 are both even. I could just start by dividing by 2 and then keep dividing by 2 until I couldn't anymore. So if I do 200 divided by 8, that is 25. And then 16 divided by 8 is 2. So 25 and 2 don't have any more common factors, so that would be my final answer. You could have also kind of reduced from this step if you wanted to, like kind of saying that these cross cancel if you would like. Okay, so the next problem, I'm just going to throw a little dotted line up here so we don't get confused. So I have 3 to the third power times 2 to the negative fourth power times 4 to the negative second power, and then that's over 5 to the negative first times 6 to the second power, so it's definitely a mouthful. So I'm just going to kind of go through and talk about which ones flip and which ones don't first before we start moving anything. So the ones that have the negative exponent, those would have to flip. So the 2 to the negative fourth power would go down. The 4 to the negative second power would go down. The 5 to the negative first power would come up. So the 3 to the third power and the 6 to the second power, those are the only ones staying in the same place because those are the only ones with a positive exponent. So we have a lot going on. We're going to go piece by piece. I'm going to just kind of set up my fraction bar just so we can go left to right and kind of fill things in. So I'm going to start in the numerator. So I have this 3 to the third power, and it's positive. It has a positive exponent, so that's going to stay in the same spot. And then next I have this 2 to the negative fourth power, which that has a negative exponent, so that's going to move downward. So I'm going to put a 2 to the positive fourth power down here. And we're not going to worry about what's down there yet. We'll take care of that after. And then next I have this 4 to the negative second power. So it has a negative exponent, so that's going to move down also. So I'm going to put a 4 to the positive second power down here. So we've taken care of what was originally in the numerator. We've done all of this. So now we just have to worry about what's in the denominator, and some of it will move and some of it won't. So the first thing in the denominator is the 5 to the negative first power. That has a negative exponent, so it's going to move upward. So I'm going to do times 5 to the first power. And it's positive 1 now, and 5 to the first power, it just means 5. So when you have just a 1 exponent, you don't need to write it, so we can technically take that off. And then next we have this 6 to the second power, which the 2 is positive, so it's actually going to stay in the same spot. It's going to stay in the denominator. Okay, so feel free to just kind of rewind the video if you want to rewatch that just to see how we ended up with everything in each spot. I'm going to go ahead and start multiplying through to simplify everything. I'm going to keep my fraction for now. So 3 to the third power means 3 times 3 times 3, which is 27. And then times 5, that can't simplify yet. And then in the denominator, I have 2 to the fourth power, which is 4 2's being multiplied together, so that's 16. 4 to the second power means 4 times 4, so another 16. And then I have 6 squared, which is 36, so times 36. And I'm just going to multiply each number together, so I'll do 27 times 5 for the numerator, which is 135. And then 16 times 16 times 64. Sorry, 36, not 64. So 16 times 16 is 256, and then times 36. I got my numbers mixed up. So in the denominator, 16 times 16 times 36 is 9,216. And then sometimes your workbooks will like have you reduce everything, and sometimes they won't. But either way, I just want to make sure that you like know how to. So we just want to divide by a common factor. So if you're not sure, always start like kind of low, and then you could just divide by higher numbers as you get more comfortable. I'm gonna divide these both by 9 though, and this can always be like a guess and check process. You don't have to know immediately. You can just use a calculator to guess and check until you can't divide numerator and denominator by the same number. So I'm gonna divide both by 9. 135 divided by 9 is 15, and then 9,216 divided by 9 is 1,024. And then like I know that the factors of 15 are just like 1 and 15, and then I can also do 3 and 5. So I'm just going to check to see if 1,024 is divisible by any of those. So 1,024, I know it's not going to be divisible by 5, but I can check 3, and it's not. It ends up being a decimal. So that just means that we can't reduce any further. But like I said, reducing is not like something you have to do in your head. You can just kind of guess and check until you can't anymore. Okay, so the next section is properties of exponents. This is like a good time to like kind of pause the video, take a brain break if you would like to, but if you're good, you can power through. So this table has all of our properties of exponents. We'll learn them kind of as individuals, and then we'll eventually start to combine them. So I'm going to expand each of these examples just to kind of show you why the properties are what they are, as opposed to just kind of showing you a formula. So the first one is the product of powers, and the example is 7 to the third power times 7 to the fourth power. So if I were to expand 7 to the third power, that means 3 sevens multiplied together. So 7 times 7 times 7, that's my 7 to the third power. And then for my 7 to the fourth power, that means 4 sevens being multiplied together. So times 7 times 7 times 7 times 7. And then we're not going to worry about like the big number answer. We're going to worry about like the exponent version answer. So now I have 1, 2, 3, 4, 5, 6, 7 sevens being multiplied together. So I can write that as 7 to the 7th power. And then we just kind of want to look at, okay, where is that 7 exponent coming from? Sorry, they're the same number. But I found that by taking like these 3 sevens that were being multiplied together and then these 4 sevens that were being multiplied together to get this exponent of 7. So that means that when we have two powers that have the same base, both sevens, and they're being multiplied together, we can add the exponents. So 3 plus 4 is 7. So our shortcut is adding the exponents. And the formula, this is just going to be kind of like the version that doesn't have any numbers in it. So if I have, say, a to the mth power, and that's just like any exponent, times a to the nth power, I can simplify it into a raised to the m plus n. So I just add the exponents together. And then the next one is the quotient of powers. So I'm just going to go ahead and expand that. I'm going to create my fractions. So I have in the numerator 5 to the 9th power. So I have 9 5s being multiplied together. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Got to make my fraction a little bit longer. And then in the denominator, I have 5 squared. So I have 5. I have 2 5s being multiplied together, so 1, 2. And then we know when we like divide one number by itself, it kind of cancels out. So like I can wipe these out, I can wipe these out, and then now I have 1, 2, 3, 4, 5, 6, 7 5s being multiplied together. So my answer is 5 to the 7th power. And then if you'll notice, I started with like 9 5s, and then 2 of them canceled out, so I was left with 7, so I was subtracting the exponents. So our shortcut is to subtract the exponents. And I would really recommend, even if it's not right now, making a table like this for yourself so that you can follow along with. And then the formula, if I have a to the mth power over a to the nth power, I can simplify it into a raised to the m minus n. So I subtract the exponents. And it doesn't always have to be like the one on top minus the one on bottom. It's just wherever the higher power is, like initially, that's where the base is going to stay. So I'm just going to write a quick example really quick of what that means. You don't need to write this because it's not going to be related to the next line. But let's say I had 5 squared over 5 to the 9th. Well, the higher power of 5 was in the denominator. So that's actually where the 7 is going to stay, the 5 to the 7th, and then the numerator would just be like a 1. So just keep that in mind. Wherever the higher power is to start, that's where your base is going to stay. Okay, so before we move on, it's really important that we know that these two those two properties, they need to have the same base. So notice like the base on both of these was 7 and the base on both of these was 5. That has to be the case to use those properties. So leave a note that says need same base. Okay, and then 0 power. I'm actually going to change this example a little bit just to save us like some writing. I'll wipe off the whole thing. I'm going to change this from 4 to the ninth, or sorry, yeah, 4 to the ninth into 4 to the third, just to save us a little writing, a little time. So the best way to show the 0 power is to expand it. So 4 to the third power means 4 times 4 times 4, and then over 4 times 4 times 4. And then I know that if I use like this property up here, the quotient one, it tells me I have to like kind of subtract the exponents whenever I'm dividing. So if I were to subtract 3 minus 3, that becomes 4 to the 0 power. We're like, okay, what does that mean? If I were to expand it, 4 divided by 4 cancels, another 4 divided by 4 cancels, and the third 4 divided by 4 cancels. So when everything cancels, I'm just left with 1. So my answer to 4 to the 0 power is just 1, and it's kind of weird, but that's always the case. So anything to the 0 power is always 1. And then our little formula is just going to be x to the 0 power equals 1. Okay, the next one is the power of powers. So when you have a power raised to another power, so like to the third power to the fifth, you multiply those exponents. So if I were to expand it, each one of these, like 2 to the third power, is like 3 2's being multiplied together. So it'd be 2 times 2 times 2. And then I'm raising that to the fifth power though, so I actually have 5 of those. So I'm gonna have 5 of these guys right here. So we'll expand it. So times 2 times 2 times 2 times another 2 times 2 times 2 times a third, or sorry, a fourth, 2 times 2 times 2, and then times a fifth. So 2 times 2 times 2. So I took let me erase some of this clutter. I took my 2 to the third power and I multiplied it 5 times by itself. So 1, 2, 3, 4, 5. And then we can count how many 2's we have now. We should have 15. So it becomes 2 to the 15th power. So the shortcut there is to multiply the exponents. And then the formula would be a to the m raised to the nth power becomes a to the m times n. So you are multiplying those exponents. The next one is a power of products. So this is the case when these inside the parentheses are not the same base, so we can't really combine them. But when that's the case, this property kind of looks like distribution. We don't use that word because it's not technically the same operation. But what we're going to do is we're going to take the exponent and we're going to apply it to both. I think I'm getting ahead of myself actually, so we'll just go ahead and expand it first. So 2 times y to the fourth power means I have 4 of these multiplied together. So I'm going to do 2 times y times 2 times y times 2 times y, and then times one more, so times 4 altogether. And then now we can just kind of count like how many of each that we have. So it looks like I have 1, 2, 3, 4 2's. So I'm going to say that's 2 to the fourth power. And then I have 1, 2, 3, 4 y's. So that is y to the fourth power. And then now I can kind of backtrack a little bit to what I was saying before. It kind of looks like we just took that 4 and we applied it to both the 2 and the y, which is what we did. So we got 2 to the fourth, we got y to the fourth. So if you want, you can use the word distribute if it helps you. I'm going to use the word apply. So apply the exponent to each factor. Oops, factor in the parentheses. Okay, so factors are just numbers that are, or terms, I guess, that can be, sorry, not terms. Factors are just two pieces that can be multiplied together. So they don't have to be like two numbers. It can be a number and a variable like it is here, but in this case, like 2 is a factor and y is a factor, so they each get that exponent. So it becomes 2 to the fourth and y to the fourth. Okay, and then the formula, I'm going to say x times y to the mth power would become x to the mth power times y to the nth power. So the m goes to both of them. And then the last one, the power of quotients, is like very similar. So I'm going to go ahead and expand this. I have 2/5 and then raise to the third power, so I have 3 of those. So it'd become 2/5 times 2/5 times 2/5. And then in the numerator, I have 1, 2, 3 2's being multiplied together, so that's 2 to the third power. And then in the denominator, I have 1, 2, 3 5's being multiplied together, so that's 5 to the third power. So it looks like the same thing here happened as the last type of property, where this power just went to both of them. In this case, it's a numerator and denominator because we had a quotient, but it works the same way, it just goes to both. So for the shortcut, I'm going to say apply the exponent to the numerator and denominator. Or you can say to like the top and the bottom of the fraction if that's easier. And then for our formula, I'm going to say x over y, and that's going to go in parentheses to the mth power. And then that exponent is just going to get applied to the numerator and denominator. So it become x raised to the m over y raised to the m. Okay, and then the last two examples. So just kind of combining the properties, something that gets really tricky about these types of problems, which to be honest, like this is kind of a tough chapter to start off the year on, but it's just kind of the order that our book goes in, or I guess our workbooks. The toughest part about this is when you have to combine more than one property. So for the first example, I'm going to zoom way in. So I have 4 times 5 squared raised to the 6th power. So inside the parentheses here, I can't multiply the 4 and the 5 because they don't have the same base. So first I'm going to have to try to figure out what to do with this 6th power. So for that one, I'm going to use the power of products property. And you don't need to like have the names memorized. You just basically need to know what they do. That means that I have to take that 6 exponent and apply it to both the factors inside of the parentheses. So what that looks like is I'm going to get 4 and take that to the 6th power. And then I have 5 squared, and that's going to be raised to the 6th power. But then now I have another property that I have to use here because I have 5 squared to the 6th power. So that one's the power of powers, where you have one exponent raised to another one. And then when that was the case, we had to multiply the exponents. So I'm going to take the 2 and the 6 and multiply them together. So I'm going to copy over the 4 to the 6th, and then times 5 raised to the 2 times 6, so it becomes 5 to the 12th power. And that number is going to get pretty big, so I think if you ever have a number that big, you can just leave it in exponent form. If the workbook gives you a hard time, let me know. So we have 4 to the 6th times 5 to the 12th power, and at this point, we're done. If we don't actually use the exponents, we have to leave it like this because we can't combine the 4 and the 5 using any properties because they don't have the same base. So we'll leave it as 4 to the 6th times 5 to the 12th. Okay, and then the last one, feel free to go back and rewatch any of the examples if you need to. But we have 5 over 3 to the 4th raised to the 2nd power. So I'm actually going to zoom out and look at our properties. So in this one, we have a quotient, which a quotient is just like a fancy word for like something we're dividing. So we have a quotient raised to a power. So we're going to use the power of quotients property right here. And that says that we have to apply the exponent to the numerator and the denominator, so that's what we're going to do. So this 2 is going to get applied to the 5 of the numerator, so it becomes 5 squared. And then it's also going to get applied to the 3 to the 4th power in the denominator. So I'm going to have 3 to the 4th power to the 2nd power. And then down here in the denominator, I have another power to a power property that we used in the last problem. So when I have an exponent raised to another exponent, I have to multiply them together. So this is going to become 3 to the 4 times 2, so 3 to the 8th power. And then that 5 squared, I'm just going to copy over into the numerator. And then I'm just going to leave it like that. I'm not going to get kind of my number without, or my final answer without exponents. That 3 to the 8th power is going to get pretty big pretty quickly. And I can't simplify anything beyond this just because the 5 and the 3 are not the same base. So I can't use that property where I subtract the exponents. So 5 squared over 3 to the 8th power.